In this precalculus algebra video, we're going to talk about finding horizontal and vertical asymptotes of rational functions. So I thought we'd start off with a couple of examples. So in this first graph, we're going to be discussing vertical asymptotes. This function has two vertical asymptotes. The vertical asymptotes are vertical lines. So do you see how the graph here, that's solid, it's going to infinity as the the x-coordinate gets closer and closer to 3 from the right. So what matters is that the function's getting larger and larger as x approaches 3. So for that reason, we say that the line x equals 3 is a vertical asymptote. And likewise, when the x-coordinate approaches -2 from the right, the function goes to -infinity. So for that same reason, right, because the function is going to -infinity as x approaches some number, we say that x equals -2 is a vertical asymptote as well. So these are both vertical asymptotes. So notice that vertical asymptotes are vertical lines, okay? They're not on the graph. They're lines. They're like walls that the graph is approaching as x gets closer to that number. Now in this case, the graph, x approaches 3 in this case from the right, x approaches -2 from the right. But we could have other functions where x approaches numbers from the left and goes to infinity or -infinity. Either approaching from the left or from the right and going to positive or -infinity is what gives you a vertical asymptote. And the vertical asymptotes are vertical lines. Now for horizontal asymptotes are horizontal lines. So what matters is what happens as x goes to infinity or as x goes to -infinity. That's what you do to find horizontal asymptotes. So here I can see that as x goes to infinity, the y-coordinate is approaching +2. So for that reason, we say that the line y equals 2 is a horizontal asymptote. Likewise, as x goes to -infinity, I can see that the graph is approaching, the y-coordinate is approaching -5. So for that reason, y equals -5 is also a horizontal asymptote. Okay, so these are horizontal asymptotes. Okay, so let's give a formal definition of vertical and horizontal asymptotes and take a couple of examples on how to find them. So definitions. First of all, the line x equals a, so this is a vertical line, is a vertical asymptote if the function, or if the y-coordinate goes to infinity or -infinity as x approaches a from the right, or if x approaches a from the left. This little positive means that you're coming at a from values of x that are slightly larger than a. And if there's a little negative here, that means you're approaching a from the left. That is, x is approaching a from the left. So if you approach a from the right or from the left, and the y-coordinate approaches infinity or -infinity, then we say that x equals a is a vertical asymptote. Likewise, the line y equals b is a horizontal asymptote if the y-coordinate approaches b as x goes to infinity or as x goes to -infinity, as we saw in the previous graph. All right, let's see some examples on how to find these. So let's find the horizontal asymptotes first of this function f of x equals 3x squared plus x plus 1, all divided by 2x squared minus 4. Okay, so for finding horizontal asymptotes, we're going to employ a little trick. So what we're going to do is we're going to divide both the numerator and the denominator by x raised to the largest power we see in the denominator. So the largest power I see in the denominator is x squared. So I'm going to divide numerator and denominator by that. So you put parentheses around the numerator first, and you write 1 over x squared. Okay, that's going to divide that numerator by x squared. And we do the same thing for the denominator. So we get 1 over x squared there as well. And we can do that because 1 over x squared divided by 1 over x squared is just 1, because these are the same. Now when you do that, what do you get? Well, the 1 over x squared gets distributed because it's addition right here. And it's going to be 3x squared over x squared. So 3x squared over x squared plus x over x squared. And then plus, and the x squared is always in the denominator, right? Because it's 1 over x squared. So 1 over x squared. That's all for the top. And then for the bottom polynomial, distributing as well because it's subtraction, it's going to be 2x squared over x squared. And then minus 4 divided by x squared. Okay. Now, why did we do that? Because remember, with horizontal asymptotes, we're asking ourselves, what happens as x goes to infinity or negative infinity? So let's ask ourselves, what happens, let's start with this, what happens as x gets large? So we're thinking, as x goes to infinity, what's going to happen? Well, x is getting big, but x squared is getting bigger a lot faster, right? So for example, if x was, x is going to infinity. If x was, let's say, 1,000, right? This would be 1,000. But if x squared, that would be 1,000,000. So the denominator is getting larger a lot faster than the numerator. And what's happening is this whole fraction is getting smaller and smaller. So we draw an arrow through it and write 0, indicating that as x goes to infinity, that fraction, x over x squared, is going to 0. Likewise, 1 over x squared is clearly going to 0 as well, because the denominator is getting large, but the numerator is not changing. So that's going to 0. This is going to 0 as well for the same reason. Now what about this? Well, the x squareds cancel. So this is going to be, in the numerator, that's just going to 3, right? Because x squared over x squared is 1. So you just have 1 times 3, and these are 0. And in the denominator, those cancel, and you just have 2 in the denominator because this is 0. So what we see is that as x goes to infinity, this whole rational function is heading towards 3/2. So we write as x goes to infinity. I'm not saying this is equal to 3/2. I'm saying that this function goes to 3/2 as x goes to infinity. So in other words, as x gets large, the y-coordinate, which is what f of x is, the y-coordinate is heading to 3/2. Let's write that down. That y goes to 3/2 as x goes to infinity. And for that reason, we say that y equals 3/2 is a horizontal asymptote. Okay. Now the same thing would be true if x was going to negative infinity, right? Because in this case, positive or negative infinity didn't make a difference. So in this case, we only had one horizontal asymptote, and it was y equals 3/2. Now, what about this one, the horizontal asymptote of this function? Well, applying the same trick, we're going to multiply by, or in this case divide, but it's multiplying because it's 1 over that. 1 over the largest power we see, so 1 over x squared. Now, this 1 over x squared, it's always the largest power you see in the denominator. So 1 over x squared for that, and also 1 over x squared for the top. These have to be the same. Whatever you multiply by here, it's got to be the same there. Okay, and when you do that, what do you get? Well, it's going to be 4x cubed over x squared minus x over x squared, and then divided by, we're looking at, well, 2x squared over x squared, and then plus x over x squared, plus 4 over x squared. And what's happening here as x goes to infinity? Well, this once again is going to 0 for the reason we talked about above. So that goes to 0. This is going to 0 for the same reason. 4 over x squared is going to 0. And what's happening here? Well, let's talk about the denominator first. These cancel, so the denominator is going to 2, right? But the numerator, it's x cubed over x squared. So there's an extra x right there. So the numerator is actually going to 4x, and the denominator is going to 2. So what's happening is that as x gets large, as x goes to infinity, it's not going to some constant because there's still an x right here. So even though the denominator is going to some number 2, this is getting huge because there's still an x there. What that means is that y goes to infinity as x goes to infinity, right? The y-coordinate's getting, f of x is getting large as x goes to infinity. Now, a horizontal asymptote is a line y equals some constant, but that's not happening here, right? Y is not approaching a constant. Y is getting huge as x goes to infinity, and for that reason we say that there are no horizontal asymptotes. So this graph does not have a horizontal asymptote. That's our answer. Now, you notice that in this previous problem, what mattered is the lead coefficient, or sorry, the lead term, right? The fact that these were both squared means it's sort of a tie. The numerator is getting large, and so is the denominator. And at the end of the day, what matters is the lead coefficients, 3 over 2. And that's because the numerator and denominator were of the same degree. But for this problem, the numerator has a larger degree than the denominator, right? And for that reason, the lead coefficients didn't matter. What happened was the top polynomial was dominating, So the function went to infinity as x went to infinity. Let's go ahead and summarize that with horizontal asymptotes. So for horizontal asymptotes, now R stands for a rational function. So remember what a rational function is. It's a function where you have one polynomial divided by another polynomial. Now looking at this, you want to be very carefully observe that this is x to the n, and in the denominator it's x to the m. N and m are not necessarily the same, okay? So all you have to do is consider three cases. So case one, if n is less than m, so if this number is smaller than that number, then what happens? Well, you can imagine, right? If this is larger than that, what's going to happen is the denominator, the polynomial down here, is going to dominate. It's going to get large so much faster than that numerator that when a denominator gets really large and the numerator isn't getting large as fast, the whole thing is going to go to 0. And so if n is less than m, that if that number is less than this number, y equals 0 is a horizontal asymptote. What happens if n and m are the same, if they tie? Well, that's the case that we talked about in the previous page. If these tie, if they're both 2 or if they're both 3, then y equals the quotient of the lead coefficients is a horizontal asymptote. So at the end of the day, it's this coefficient divided by that coefficient. Y equals that quotient is your horizontal asymptote. And then finally, if n is greater than m, that is, if this number is larger than that number, then the numerator dominates, and the whole fraction is going to run off to infinity, because the numerator is getting larger so much faster than the denominator. And when you have a fraction with that happening, where the numerator gets larger faster than the denominator, the whole fraction blows up. It goes to infinity, and there would be no horizontal asymptotes. So when you're looking for horizontal asymptotes, all you have to do is classify it into one of these situations to find what you've got for horizontal asymptotes. Now what about for vertical asymptotes? Let's see how that works. So for vertical asymptotes, we have a different strategy. We're first going to factor both the numerator and the denominator, and then simplify. Once you've simplified, all we're going to do is find the zeros of the denominator, and those are going to be our vertical asymptotes. So for example, find the vertical asymptotes of this function. Okay, first we factor and simplify. So we have f of x is equal to, factoring, we get x plus 2 times x plus 3 divided by, well, let's see, it's going to be x times x squared minus 4. And we can factor that farther, right? It's x plus 2 times x plus 3. And the denominator is going to be, well, it's a difference of squares, x times x plus 2 times x minus 2. And now we can cancel. The x plus 2's cancel, and we have this. X plus 3 divided by x times x minus 2. So where are your vertical asymptotes? So I'm writing vertical asymptotes VA. So remember, the vertical asymptotes are vertical lines. And according to this, the zeros of the denominator give your vertical asymptotes. So the denominator, when is that 0? Well, when x equals 2, that's one of them. So this function is a vertical asymptote when one vertical asymptote is the line x equals 2, but also it occurs when x is 0. So the line x equals 0 is a vertical asymptote as well. And the reason these lines are vertical asymptotes is because as x gets closer to those numbers, what happens? Well, the numerator does not approach 0, and we already guaranteed that by canceling out any common factors. So for example, as x approaches 2, the numerator is approaching 5, but what's happening to the denominator? Well, it's approaching 0. And when a fraction has that situation where the numerator is approaching a non-zero constant and the denominator is approaching 0, the whole fraction blows up and it goes to infinity or negative infinity. And that's what gives rise to a vertical asymptote. So what we're going to see in the next video is we're going to graph rational functions, and we're going to make use, one feature we're going to be interested in is finding horizontal and vertical asymptotes. And with vertical asymptotes, we have to know, hey, does the function go to infinity or negative infinity as you approach those numbers? And we'll go ahead and talk about that in the next video. Graphing rational functions, part 2. All right, until next time.